Well, now I want to introduce Sherry Johnson, who owns Cat's Paw, which has been in business for many years. I'm sure you're familiar with it. But Sherry's coming out with a brand new product that, frankly, I'm excited about because I think it's going to really do something special for our model railroads. It's called InvisaTrax, and Sherry's going to demonstrate it for us this evening. Sherry, welcome.
Great. Thank you all. Glad you're here. Let me go ahead and get my screen shared. And this is going to be a two-part process. The first part, I'm actually going to focus on getting the InvisaTrax product installed, which I got that done. And this photo is not my final landscaping. I didn't get it done. That will be done for next week. But what we've got is I have a customer who wanted a desktop display done. And basically, we're going to have moonshine mics sitting up on top of the hill. And we're going to have these two little revenuer guys wandering around down below looking for said still. So we're going to use the InvisaTrax system to make those guys move. And the process, I'm going to skip this slide because I realized I talked through most of it anyway. So the first thing I'm going to do is decide what it is I want to move. And as I said, we're going to be moving our two revenuers. Haven't named them yet, but I've got two of them here. First one's got an axe, so he is ready to chop up the still, and the second one's got a shotgun, so he can take care of any problems. And since I want to move both of these figures at the same time, I'm using a clear sheet of polycarbonate. I love this stuff. It's great. It's 0.01 inch thick. And I'm going to place my figures on it, kind of figure out how I want them side by side or behind each other or kind of off to the side. And once I've made my decision on where I want them, I'm going to sketch around, as you see very poorly, with a Sharpie so I can kind of cut out the plastic for just their base. And I'm just using some museum tack to hold them in place at the moment while I make the cuts. Next up, here we have two chain links that are part of the InvisaTrax system. And what I've done is I have kept two chain links out that I keep magnets in. That way, when I go to do other scenes or figures, I know that I'm going to be able to get my polarities correct. And in the instructions for the InvisaTrax, there's a whole detail about dealing with the magnets. I'm not going to go into that here. But what I've done is I have taken my figures, still with just the museum tack, sat them on top of the chain link, and marked, here in this third picture, I've marked where the magnets are underneath. Now, the system works by having a magnet in the chain and then corresponding magnets on the base. And these magnets on the base, as you can see, are very teeny tiny. They're actually 2 millimeters by 0.5 millimeter thick. We give you a lot of them in the set because you lose a lot of them. I'm still finding them stuck actually on one of my lamps on my workbench. So with my magnets or my plastic marked, I'm going to put a couple of drops of super glue. I'm going to get that little magnet on the tip of my finger, and I'm going to get it close to the base where the magnet is, where I have it marked and where the super glue is. And when I get just close enough, the magnetic attraction is going to pull that magnet over and plop it onto the base. By doing this, I know that my magnet's in the right spot, and I know it's got the right polarity. I repeat that for the second magnet because we got two of them here. If I didn't do two magnets, we'd have a guy spinning around in a circle. So we got two so that they go forward. I let the magnet dry. I gotta let the super glue dry. If not, the magnets stay behind and the base moves forward. Now that my revenuers are out of the way, it comes to the planning part of the layout. Now, this project is actually being built in a rectangular serving tray. I'm going to actually build the layout on the bottom and mount the electronics on the top. So to play around with different designs, I use string. I love the string concept. It lets me take it, lay it out. My first thinking was I was going to have one mountaintop in the middle and then have the revenuers going around that. And then I decided, well, maybe I want the whole mountaintop in the corner. So I kind of came out with this little, actually it looks like a stocking shape over here on the right-hand side. So I've kind of decided that's the layout that I want to go with. I grab my InvisaTrax pieces. I grab some turns. We've got 180-degree turns. We've got some 90-degree turns. And we've got some different length track sections. We got 14 units, an 8-unit, and 4-unit, and 2-unit. And in the instructions, we actually have what those links are, how many inches they are. So you can kind of measure what's going on. But I want to kind of just lay in and kind of what I call blocking in what I'm doing here. So I take my pieces and I block it in on top of the string. And I kind of decide that, yeah, I really like the idea of having the mountain in the corner. I take my pieces off, I take my string, and I mark it so that I know how long my track run's going to be. And my track run's going to be approximately 48 inches. This is going to come in handy later when I need to figure out how many chain links I need to use. Now, in my design, I had rounded edges. We weren't going to do it blocked in. So I'm going to test fit everything in place by using double-sided tape. This is great. It's strong enough to hold the track pieces in place, but will still let you pull them up and move them around if you need to. So I've taken my parts here, and I've got a 180-degree piece that I'm going to use where I'm going to put my motor. And then I have a 90-degree turn, because it's a sharp turn going around the mountain there, where I'm going to put in a bearing turn. And now I've got 3 organic turns. One of the great things about our system is the track is flexible enough to bend to get these organic turns. Now, if you bend it a lot back and forth, as with any plastic, it'll break. But if you're just trying to bend it and get it in there, you can see that this works pretty cool. I trace around the track so that when I remove it, I know where to put it back. I've marked up here in the upper left-hand corner the part where the motor is going to be with that little circle with little sprigs around it, because my motor is going to be mounted through the wooden base. And basically I use a 3/4 inch Forstner bit. You could use anything else to drill a hole. It just needs to be 3/4 of an inch, because that is the size of the motor. The motors we use for the system are very small. They're N20 motors. They take up very little space, but have a lot of torque for their size. So I drill my hole. I've mounted my motor to my motor turn. I'm going to feed my wire through the hole. Again, using double-sided tape, I'm going to mount that drive motor section to my wood piece. And here I'm showing the motor hanging out underneath. And the motor is actually short enough that it fits in the top of that box. It's only like 3/4 of an inch deep. Now, in this particular project, it's going to be self-contained. So I'm going to mount the electronics, the control system, and the battery holder all to the underside, which is now actually the top, to this rectangular tray. We actually include the battery holder and the control system in the motors in our system. You get everything you need in our basic package to put this layout together. To mount the control circuit, it has a potentiometer on it. Just needs a 1/4 inch hole drilled. So I did that, mounted that in there. Cut out a section so I could have my switch, because we can reverse the directions of the track or the way it's going. With those 2 pieces in, I use a little bit heavier double-sided thick foam to actually mount the battery box, because I want it more permanent than the other really thin, cheap double-sided tape. I lay out my wires underneath and take a look at the top. It's like, okay, we've got everything put together. It's looking good. I attach the drive gear, and we've color-coded the system so that the drive gears are blue, so you know which one to go in your turn. One of the things you'll find, and that we recommend, is you test frequently. So I want to test to make sure my electronics are working, and I hit it. And my drive gear is working, which is awesome. That means my electronics and my wiring is good, my batteries are good, and my drive gear is not binding on anything in that corner. And this is still all just temporarily mounted. I'm going back now that I have my drive gear in place, and you can see it with the blue gear. I'm putting the track back together, putting that bearing turn in, putting more organic turns in, sticking it back down at this point with double-sided tape. And you can kind of ignore that little extra motor hole there. I was actually going to do something else with this and drill the hole in case I wanted to, but I changed my mind, so you can ignore that hole. As we noted with our string length, we said that we had about 48 inches. And each of our little individual chain links are approximately 3/4 of an inch. So doing the math, I came out that I needed a roughly 61 chain links. Notice right there, the two shiny ones in the middle. I've got my magnets. I got 2 chain links with the magnets inserted right there in the middle. And I snap all my chain pieces together. And you can see up here in the upper left-hand corner, I've got a little bit of space, but if I pull real tight, I can snap the chain together. You can see it gets hooked. I drop it down into the track, press it in there, take a look. It's looking good. And we're getting ready for test number 1. Okay, I got the chain in there. I got the motor going. I'm going to have a little help from my assistant, Olive, here. She's going to let me know if this is working or not. And we hit the power switch, and nothing's happening. Now, we know that the motor works because we tested the electronics already, so that means something is wrong with the drive system itself. In this case, my chain was too tight. The motor wasn't strong enough to move the chain. So we come in and we have a couple of different options here. I can add another chain link, which I did, but when you take a look, when I have done that, my chain starts bunching over here, which means by adding that whole length, my chain is now too loose. We have another piece that we offer, which is like a 2-unit section, a 2-unit chain piece. I call it a connector piece. We include a couple of those just for this instance, for when adding a whole link is too much, but you need something in there. So I put this piece in, and you can see that it's looking better there on the right. There's a little bunching, but not like there was before. Being the optimistic person that I am, I decided to go ahead and test and see how it worked. And we can see without any load on top that it works pretty good. I always test going both directions because sometimes it'll work one way and it won't work the opposite direction. But this moved pretty good. Next, I'm going to test with an actual load, because just because the chain moves without anything on top, that's great. But once you add the magnets and the extra friction and drive force of the object you're moving, it creates, it's going to need a little more torque, a little more power. Now, I didn't have my revenuers done in time, so these are just 2 figures that I had from a previous project. I have covered the entire box with another piece of that wonderful polycarbonate sheet. Like I said, I love this stuff. Tacked it down on the corners with some tape to hold it in place, because if you don't, when you turn this on, it'll move along with the people. So we're going to test again. And it's like, okay, we're looking good here. People are moving. There she goes, okay. And we can see that coming up on the what I call the pull side of the drive motor, everything is operating nice and smooth. Coming down the back side, which I call the push side of our system, we can see that things are kind of slowing down. It gets caught a little bit and then it picks back up. That means I probably have some bunching going on again, caused by the extra friction. Now, when we get halfway around, we're back on the pull side and things are moving smoothly again. So I did a little close-up. Sure enough, you can see, and it's kind of blurry through the polycarbonate, but you can see that with the figures on it, it changes how the chain moves in the track, and I still have some bunching here. I've got like 3-4 places where it's bunching up on the push me side. So we're going to make another change, and I decided in this case to move the drive motor from the top corner down to where the first turn was. That way it kind of puts it in the middle of the push me pull me's. I also decided that on the very sharpest, or the sharpest of the organic turns, to go ahead and put in another 90-degree bearing turn. The bearing turns reduce the friction because it's going through a gear and it moves much smoother than having the actual chain rub against the side of the track. So with this new design in place, we're going to test it again. Looks like it's working good, working much better than test number 2. So we're going to try it with the load on top. And coming into the pull me side, we're still looking good. Coming off the pull me side, we're better than we were, but not perfect. Now, I thought about leaving it this way because if I did, that way my little revenuers would kind of slow down and it might look like they got a hint of where moonshine might be. But I decided I wanted a smooth operation because later I might go back with a microcontroller and actually program my revenuers to slow down in specific spots. So we're going to do another little redesign. And this time I'm going to add a second motor. This way I'll have pretty much an even amount of pull me and push me's. Okay, we're going to test this. And I'm just going to go ahead and, come on, there we go. And why it did that is beyond me. Let me see if I can go back. Okay, let me go back. Is that, there we go. Okay. So with the 2 motors in there, you can see we have a very smooth operation with just the chain itself. I put my polycarbonate back on top. Try it again with my load. And we can see that we've got nice smooth movement coming into the first motor turn and its sharp turn. The area where we were having problems, which was right here, is now nice and smooth, no jerky motion there. When we get to this turn, we're back on a pull me side, so that second motor is smoothly pulling that load across there. And this would be the next area we would need to watch for potential issues. But since we have our first motor, this whole side is back on a pull me side. So we have nice, smooth movement. Notice no jerkiness. Everything is going very, very smoothly. Once we have our design set and it's tested, we go ahead and we permanently mount the track. Now, in this case, if you notice in the tracks here, there are a bunch of little holes. These holes will accommodate wire nails. They will accommodate 1.mm or 1.6 M wood screws, which is what I used in this case to mount the track to the base. When I do my layouts and I'm doing it in the pink foam, I usually just use the nails. If I'm putting it into a routed channel, I use the nails versus the screws. It's just easier. Okay, going to do a close inspection here to see how again, looking for any bunching, which of course you can see I've added. I was, again, being optimistic. I already added some of my brass screws. You can see I added them at key points where the motor turns are mounted. I added them where there's organic turns or anywhere that the track might shift from having the chain rub against it. I put in the screws. I leave some of the spots open because later on, when we get to the landscaping part, which will be next week, I'm going to show you how I can actually mount some of my ground covering into those screws as well. But you can see here, the chain is operating really, really smooth. And I'm going to be quiet for a moment. And that's the total volume of the system. So as you can see, it's not making a lot of noise at all. And this is without any deadening. This is on a hollow wood box. So the system is very, very quiet. Now, I love testing at multiple speeds. We saw it works good slow. Well, actually, these flipped, okay. I actually have my revenuers here, so I'm testing my revenuers, and this time I'm testing going the opposite direction. I mentioned before, I always do tests going both ways. So here we have the revenues going the other way because when you go the opposite direction, your push me pull me's will be the opposite direction. So you need to test both ways. And my revenuers are looking good. No bunching coming around this side, because back again to the pull-me's. And I love this one up here because this would be the flash. This also lets you know that the chain is in there. It's good. If it runs slow, it's great. If it runs fast, you know you've got no binding, no glitches, because in the fast speed, if there's any spot it was going to catch, it'll catch on the fast and it'll lock the system up. That's it for tonight. Like I said, next week we're going to take a look at doing the actual landscaping, putting the ground cover on, the permanent ground cover and stuff like that. The materials that we used was the box, the polycarbonate sheet, which I ordered that stuff. I order it and it's like $6.48 for a piece that's 24 inches by 48 inches. I love that stuff. I use it for a whole bunch, and you'll actually in our set get a piece of that that's 3 by 5 inches to use to mount figures to. Double-sided tape, super glue, of course. Cat's paw. We used the expanded set. Everything to do this particular scene is included in the expanded set. And our revenuers, which are up on the Cat's Paw site for sale. And the parts, the total parts that we used here, we used 2 90-degree motor turns. We used a 90-degree bearing turn and a 180-degree bearing turn. Associated gears. 2 of the really long track pieces, 1 of the second to longest and 2 of the second to shortest track pieces. I have here that I used 88 chain links, but I don't think that's right. I think I miscounted. We have the cube magnets that are mounted in the chain, the disc magnets that are mounted on the base that the revenuers are on, the DC motor controller, which you saw mounted, and the battery holder. The only thing we don't include is the batteries. Tools, I used my drill, Forstner bits, sandpaper, pretty much tools that anybody would have on hand. And that brings me to the end of that. So now we get to go for questions.
Anybody have any questions for Sherry?
I have one question, Sherry.
Yes.
A dry lubricant would help that chain go around better, or something you could spray on, or?
I've actually tried the dry lubricant, and with the materials that I'm currently using, it doesn't really help because I'm using a nylon gear with a PLA drive system. When I was using different materials, the dry lubricant would help, but this doesn't. When that first test, I just had it too tight against those organic curves. It just wasn't doing. But I have used, and if you sometimes you might want to try. And I've used the stuff that you get for like the Pinewood Derby cars, the white powdery graphite.
Mm-hmm.
I've used that, but I didn't really notice any difference.
Thank you, Jerry.
Mm-hmm. Other questions?
So Sherry, I don't have to be an electrical engineer or something like that to be able to use this system, right? This is pretty simple.
Oh, yes. Matter of fact, it's so simple that my 76-year-old sister, who has to write down instructions on how to use the remote for her TV, can do this. She's been my guinea pig. She with the instructions, we've got very detailed instructions. She reviewed those, and we have how to hook up the motors is very simple. There's no soldering required. It's just you need a flathead screwdriver, and you can hook up the motors. It's like it's very simple. The track pieces press together, the chains snap together. It's very easy to assemble. Once again, like I said, my 76-year-old sister who has arthritis could get it together without any problems. Matter of fact, I have to do a Christmas thing for her this year with Santa on a snowmobile for her Christmas table display. She's anxiously awaiting that. So,
well, thank you so much for the demonstration tonight. We'll look forward to seeing you next week.
Okay, and it's partially landscaped, and let me tell you, with the grass on it, it looks really cool when you don't see the workings underneath.
Thanks so very much.
Thank you.